Good morning friends. Today in this PK technical classes we'll see how the most transistors are accumulated to create a NOR gate for 3 input and 1 output. So here in the diagram we can see 4 inputs are there for NMOS and PMOS, but we will going to design a 3 input and 1 output NOR gate. So this is the diagram actually which we have to design, but for designing this diagram we will go to the next software which is known as DSCH, and after that we will go for Microwind to design layer by layer for this NOR gate. So let us friend will next go to the software to design for DSCH first. Let us see how in this DSCH platform the gates are being designed. We'll select different type of gates and different type of in this lecture sessions like NOR gate. Today we are going to make NOR gate using the MOS transistors. These are the PMOS which we are selecting. So we are placing just PMOS transistors likewise, and we'll make the diagram, and then we'll connect it as per our requirement. These are the channel length and channel width as we can see. So next we'll connect the VDD supply over here, and then these are the PMOS which I have made. Then we'll make the connections, particularly as we are going to making the NOR gate implementation. And so let us friends see how this software works actually using this PMOS and NMOS transistors. So let us take these transistors likewise which are the NMOS, and by creating this diagram we'll successfully see that how the NMOS and PMOS combinedly going to make the NOR gate. So, and we can see that this is a format of 3 inputs and 1 output. So we'll place the ground connection over here, and we'll ground the terminal, and we'll connect these terminals likewise as it has been connected. Then again we are going to select the wires to the ground connection as shown in the diagram. So these are been connected, and we have been connected these diagrams. So the wire has been connected like this. We are connecting the wires. So the connection process are been going on. So first of all taking this circuit diagrams likewise, and we are going to make the diagrams, and then we are going to put the first input likewise. So from this type of diagram we are going to put the first input to our terminals. So we will put the input, and we can also, if we required, we can also change the name of the inputs also, as it is given input 1. We can also try to, if we want, we can also change the name of the input, but for this time we are not going to change the name of the inputs because next combinations are over there. We are going to make the next connections and let us see that how these next connections are being made. So we are going to connect. We'll put the node point assigned over here and we'll connect it for the second transistor, and in the gate terminals of both these transistors we'll connect the second input 2 and connect it likewise. Then for next transistors portion we are going to connect these transistor connection portion likewise, and we will connect this third transistor assigning the node point by connecting it with the last transistor likewise. I am going to connecting likewise. So the third input we are going to put, this is the third input, and we are connecting it likewise. So this is the third input, and now we are going to put the output. So output we have to put it we can put a LED over here to connect it. Okay, so let us put a LED for connecting the output over here, which will show us the output. So this is the output, and now we are going to place this node point over here, and then we have to connect it likewise. So now we have been connected this LED at this point. Okay, clear. So now we have completed the diagram fully, and next portion we will go for the stimulation. So the output of this circuit diagram can be checked likewise. Okay friends, let's check the output. We'll go for the output. So now you can see the stimulation is likewise. Suppose we are pressing the buttons likewise. If we are pressing the button out, there is no output, and when we are not pressing the outputs, we are getting the output. So it proves that it is a NOR gate, and whenever we are pressing the buttons, accordingly the PMOS are being on, and when PMOS are being off and we are not pressing the inputs, NMOS are on and we are not getting the output. So whenever we are switching on, the PMOS transistors are, we can see it by pin state also. So we can see the 0 and 1 portion over here, where if we are not putting any inputs, we can see the PMOS are being on, and the output is we are getting output, and NMOS are being opened. And whenever we are putting the inputs, we can see the NMOS are being closed but PMOS are being open, and don't care condition, there is no output. So this is our first input which we are providing for our signals for this design NOR gate by the help of 3 input NOR gate for most transistors PMOS and NMOS, which commonly give this timing diagram likewise. In this timing diagram we can compare the inputs and output. There are 3 inputs which we can compare with the output also. So these are the diagrams friends. You can see we are really thankful to all of you that you all are subscribing and you are getting these videos and learning a lot. And now we are going to next session for the microwind. We will see how the layer by layer can create this 3 input and 1 output NOR gate. Thank you friends. Today in PK technical classes we are going to design the MOSFET and 3 input 1 output NOR gate using CMOS transistors. So first of all we will select the P diffusion, and then we will select the N diffusion, as per we have selected the different type of layers. You can see what are the length according 44 clos 8 lambda. This end diffusion is like our P diffusion. We have also selected the end diffusion. Now for this time we'll have to select the metal contacts. For P diffusion we will select P metal contact, and for N diffusion we will select N metal contact. So first of all, for P diffusion we are going to select 4 metal contacts for P diffusion, and in case of our N diffusion we are going to select 4 N metal contacts. For N diffusion also we are going to select it. So first of all we'll select like this, and we'll assign like this in the surface of the diffusion. Okay, so this is our structure which we have to make. Then we'll select MOSFET, which is made up of our polysilicon material or any gas material. So this polysilicon we have selected, which is play the role of gate, or we can also say that wherever we want to put the input, we can put the input from the gate layers also. So this is our gate layer, which is made up of polysilicon, and in this software it is visible in our red color. You can say also orange, anyhow whatever we can say it, but the structure is likewise, and we have designed it likewise. So after selecting the gate layers, we have to go for the next step, which is we have to select the metal one, and metal one we have to draw the structures to combine this type of layers from one gate to another, so that the connectivity between the gates, connectivity between the transistors for this logic gate can be applicable. So just make this metal one layer contacts for the contact layer of P and N likewise, and we have to make the metal one contact for this type of structures. You can say to make the right structure, as we have seen in our other software DSCH, that how this process works effectively for 3 inputs and 1 output. So this metal one contact is our now been completed for connecting this type of structure. So after completing the metal one contacts, likewise we can also proceed for the next step, for which we have to select our VDD, and we have to place it over here likewise. And after selecting the VDD, we have to go for anvil. We have to put the anvil likewise, because the upside portion is our PMOS and the bottom section is our NMOS, and also P in the anvil structure we have given VDD. Now we are taking the clock inputs. We will name it A, capital letter A, and assign it. Again we will select for next input, which is clock input 2, and we will name it as capital letter B, and we will assign it. Again we will select the clock input C, which is clock input 3, and we will write capital letter C and we will assign it. So these are the clock inputs which we have taken. Now we will put the visible node for taking the output, and we will name it we'll change the name like Y. We can put it up and assign it, and then we have to take the ground connection, which is our VSS, and we put it over here, so we can see the output in this manner. And whenever we go for voltage to time, voltage to current, voltage to voltage, different type of plots we can get, frequency versus time, different type of plots we will get the result. Now suppose we are going to change the time scale. So if I go for changing the time scale like 10 nanoseconds, so we can see the output likewise. Suppose 20 nanosecond, we will see the output likewise. If we again change the scale patterns, will result a different type of outputs. Suppose 100 nanosecond if we put, so these are the results which we get. So these are the structure. So we have got the output. Now we see the process step in 3D, how it works. Initial substrate and diffusion, SiO2 trench isolation, thin oxide layer, thin oxide reduction, polysilicon deposit, and implant embedded DRAM. A second polysilicon deposit creates metal deposit via hole fill, metal 2 deposit and each via 2 hole and fill, metal 3 deposit and each via 3 hole and fill, metal 4 deposit and each via 4 hole and fill, metal 5 deposit and each via 5 hole and fill, MEM dielectric, metal 6 deposit, passive oxide deposition, passive etching, end of process. So this type. And on the 3D structure we can see the top view, then front view, then we can see the side views of the design which we have made. Likewise this model can be created, friends. So this is our design of 3 inputs and 1 output NOR gate by help of CMOS. Thank you, friends. Thank you a lot for subscribing the channel.